So we're going to start our session with Xiangqun Chen. The paper is going to be called Solving the Mind-Body Problem. Do we need a reductive or non-reductive neurophilosophy? This should be super interesting. If everybody please give a warm round of applause for Xiangqun Chen and have him come up and start.
And just a little note for all the speakers, I will show you a 5-minute warning, a 2-minute warning, and then I'll put up a Q&A sign. You have 5 minutes for Q&A. You can bring your presentation into that time if you would like and get rid of the Q&A, but I will stick to the schedule so we can all stay on track. All right, let's give a round of applause.
Hello, everyone. So today, I just want to give a lecture about mind-brain problems. So this problem is the core topics of the philosophy of mind, as we all know. So today, but I want to compare two kinds of methods. One is reductive neurophilosophy, and another is non-reductive neurophilosophy. I want to show which method, which solution to the mind-brain problems is more competitive. So this is my core idea for this paper. So as we all know, about the mind-brain problems, the traditional solutions, as we know, the philosophy. The philosopher always propose the methods as the monism, dualism, and also the neuroscience, the neuroscientists, they always propose the reductionism as a solution to mind-brain problems. But I think this philosophy and neuroscience, there's method and there's solutions to the traditional, the mind-brain problems. I think they have their issues. For example, as we can see, the philosophers, there's solutions to the mind and brain problems. As we can see, there is no experimental verification. And also, in the neuroscience, the neuroscientists, their solution to the mind-brain problems, and there always no conceptual argument. So I think the two solutions to the mind-brain problems in the traditional ways to the mind-brain problems, they have their own issues. So today, there is the neuroscience, neurophilosophy. The neurophilosopher want to combine neuroscience and philosophy. They want to propose a new solutions to the mind and brain problems. So what is neurophilosophy? Neurophilosophy is an interdisciplinary approach that aims to solve philosophical problems with the help of neuroscientific data and facts. It is combined philosophy, including its branches, with neuroscience, and this provides a comprehensive approach for dealing with original philosophical issues like self-consciousness and the mind-brain problem. In a word, we can say that neurophilosophy combines the method, concept, and the solutions of philosophy and neuroscience, and they combine the two to solve the mind-brain problems. So generally speaking, so as we can see, the neurophilosophy, it is a position located in the border between philosophy and neuroscience. So there are two forms of neurophilosophy. One is reductive neurophilosophy, and another is non-reductive neurophilosophy. These two kinds of neurophilosophy, the solution to mind-brain problems, they have their own characteristics and their own strategies, and their own characteristics. For example, we can say the concept of reductive neurophilosophy. What is the concept for reductive neurophilosophy? Reductive neurophilosophy states that philosophy and its branches can ultimately be reduced to empiric neuroscience which is provide a reductive approach to mental features. This is the concept of reductive neurophilosophy. For this figure, we can see that the branches of philosophy, such as phenomenon, ethics, and metaphysics, all these branches are reduced to empirical neuroscience. That is, reduced. It is unilaterally reduced to empirical neuroscience. So the characteristics of reductive neurophilosophy, there's 3 characteristics. For example, we can see the domain monism. That means in reductive neurophilosophy, there is only one domain, that is empirical domain. And all other philosophic domains are all eliminated. And second, the methodological monism. That means the empirical method as the only one approach for investigating the mind and its mental features. And all philosophical methods, such as rational argumentative method, is neglected. And third, a brain reductive stance. It is postulated that all the mental features, such as the consciousness, free will, and the self, are completely reduced to brain and its neural activities. So this is the characteristics of reductive neurophilosophy. And the strategies, of reductive neurophilosophy, it is concept, fact, reducibility. It is just a strong reductionism position that unilaterally reduced philosophical concepts to empirical data and facts of neuroscience. These philosophical concepts are empirically redefined and considered as empirical plausibility. So these strategies, the concept, fact, reducibility. So we can, from these figures, the concept, fact, reducibility. The philosophy concept reduced to the empirical, to the neuroscience. But the neuroscience can't be reduced to philosophy. So it's just concept, fact, reducibility. It is unilaterally reduced. So as the philosopher Searle said, so we require a reductive model to account for the relation between mental features like consciousness and brain. So that's the reductive neurophilosophy. It is an approach to solve the mind-brain problems. So the solution for reductive neurophilosophy to mind-brain problem, as we can see, the mind, it is concept, methodology, and ontology, all reduced to the brain. But the brain, there's concept and methodology and ontology can't be reduced to the mind. So it is just, we can say, this monism. We can say their solution is just mind-brain reducibility. Now this is the solution of reductive neurophilosophy to mind-brain problem. So let's say the concept of non-reductive neurophilosophy. So non-reductive neurophilosophy proposes an iterative linkage between philosophy and neuroscience, which provides bilateral relation between philosophy and neuroscience. So this is different with reductive neurophilosophy. As we can see, it is the relation between philosophy and neuroscience, we can see is bilateral, but in reductive neurophilosophy, it is neurolateral. So it is completely different. So we can say in non-reductive neurophilosophy, the philosophy branches like ethics, metaphysics, and the neuroscience, they're interacted. So it's just not unilateral reduced, but they are interact, right? So this is different. So we can say the characteristics of non-reductive neurophilosophy. It is different with reductive neurophilosophy. We can see the first characteristics, it is domain pluralism. That means there's many domains like metaphysical, ethical, phenomenal, and empirical domains are all considered. And also the method is also pluralism. And the brain-based stance, that means the brain is not the only condition. Now, other conditions like the body and environment are also essential and important for the mental capabilities. And the strategies, the strategies are different with the reductive neurophilosophy. It is concept, fact, iterativity. That means we can say it is bidirectional interaction between concept and fact. The philosophical concepts such as self-consciousness and mind-brain problems are interacted with the neuroscientific facts. So we can see this figure. This conceptual feedback, conceptual feed-forward input, and then the conceptual feedback output, and then we can see it's re-entrant loop. So it's just like iterativity, like this. So it's just not the unilateral reduced. So, but how does non-reductive neurophilosophy resolve mind-brain problems? As we can see, the philosopher Nosov proposed we require special temporal model to account for the relation between mental features like consciousness and brain. So in his ideas, in his opinions, he proposed a special temporal mind-brain relation, and the time and space considered as the common currency. So for example, there's mental features and neural activities. The common currency is time and space. So this is a non-reductive neural solution to mind and brain problem. So we can see these figures. The mind and brain, the concept, methodology, and ontology, there's iterative, we can see interacted between each other. So it's just not a unilateral reduced, right? So this is pluralism between philosophy and neuroscience. So we can consider it as mind-brain iterativity. This is a non-reductive philosophy, the solution to mind-brain problem. So there's two solutions. One is mind-brain reducibility and also mind-brain iterativity. There's two solutions. But which solution to mind-brain problem is more competitive? So my answer is non-reductive neurophilosophy. So why? Because reductive neurophilosophy, it has a problem of empirical ontological fallacy. For example, the reductive neurophilosophy, the brain and the mind, they are just mind is directly inferred from brain. So in empirical level and the ontological level, they just equal to each other. So there's no difference. So I think this, we can call it empirical ontological fallacy. And also, the reductive neurophilosophy can't resolve the philosophical problems of brain consciousness gap. We all know that the consciousness and the brain, they have the gap, as we can, the Chalmers proposed the hard problems of consciousness, like the qualia, and also what it's like to be a bat and explanatory gap problems. But if we in reductive neurophilosophy just equal the mind with brain, there is no difference. So they can also resolve this brain consciousness gap problem. But the non-reductive neurophilosophy, it is solution to the mind-brain problems, can avoid the empirical ontological fallacy, but it can propose the empirical ontological possibilities because there is time and space between them. The brain and mind matched with each other between the time and space. It is not just directly inferred to each other. So we can say there's empirical ontological possibilities. And also, it can resolve philosophical problem of brain consciousness gap problems. As we can see, the brain and consciousness, they have differences. But if there is time and space as a common currency, so we know, and brain and consciousness is our common sense. So this can propose a solution to the gap problems. So my conclusion is that reductive neurophilosophy makes a direct inference from brain to mind, which this implies empirical ontological fallacy. This makes it unable to solve the brain consciousness gap problem between mental features and physical features. But non-reductive neurophilosophy suggests interaction movement between brain and mind and brain, which this implies empirical ontological plausibility. This makes it possible to bridge the gap between mental features and the physical features. So, and also can solve the brain consciousness gap problems. So this is my conclusion for the two solutions to the mind and the brain problems. Thank you very much. Okay, let's.
We'll pass the mic so Zoom can hear the questions.
Yeah, sure. I'm not sure exactly how we're.
Okay.
We'll just take hands, I guess, and then we'll pass it. I'll pass it around. All right, we got one here in the front.
Thanks for the talk. I enjoyed it very much. I like this Northoff. Okay, Levinas used to say that the consciousness of time is the time of consciousness. You can also say that about space. The space, consciousness of space is the space of consciousness. Meaning, I like the approach where you actually try to use space as a bridge between, in your iterative process, and actually think it can work. But you have a serious problem that has to do with the spatial demarcation conditions of consciousness. Meaning, it's very hard, and this is one of the biggest problems with consciousness, is to place it in space. So if it has some kind of spatial demarcation conditions, how do we do it? And I'm actually working, I have some solution for this, which is kind of a little far out, but the problem is interesting.
Yeah. So you mean the space between them? You do not.
I'm saying,
Yeah.
consciousness.
Time.
If you're going to explain space somehow as something that happens in space, that unfolds in space,
Yeah.
it should have some kind of spatial demarcation conditions. Maybe where does my consciousness in space end and where does yours begin?
Okay.
We know that the two will never fuse or anything like that, right? So it's a hard problem to solve.
Okay, so that's so why is the consciousness and brain, the space and the time between them? So this empirical evidence shows that. For example, if some person has a problem of, we can say, depression, yeah, he always feels his time is not consistent with the time outside. I mean, so the time inside the depression people is disconnected with the time outside. So that means we can say consciousness, the brain and consciousness has the time as a common currency. This is the empirical evidence. So, and yeah, so if you read some neuroscience papers, you will read this. Yeah, this is math. Is that okay?
Anybody else have any questions? All right, can I ask a quick question then?
Okay.
All right, cool. Does your non-reductive approach imply a kind of ontological pluralism? I mean, are you committing yourself to there being a distinction between the mind and body, doing two different types of either substances or properties or anything like that?
You mean the two solutions, there's differences? Sorry, I didn't get the question.
So the non-reductive account,
Yeah.
does it imply
Yeah.
that the mind and brain are distinct substances? Or perhaps you might think that the mind is sort of a distinction at the level of properties or something like that? Or do you still want to bring them together? Because I wasn't sure if you were sort of articulating kind of epistemic reduction or metaphysical reduction, which one you were talking about. So,
I think for the mind and brain and the non-reductive neurophilosophy, there's differences. I mean, and the mind, I think we talk about is philosophical meanings. And the brain, we talk about is neuroscience meanings. So
we use different languages for sure, yeah.
Yeah.
But in terms of entities, at the sort of ontological level, right?
Yeah.
Are they different entities, or are they the same type of entity on your
I think they are
under a different description, perhaps?
They are different, but they have a common currency. That means they can communicate with each other because time and space as a bridge between them. So they're different. They are different, but can communicate.
But that's compatible with the kind of interaction as dualism, right? Where a kind of, for example, your view would be entirely compatible with Descartes, a kind of Cartesian dualism.
Yes.
Okay, but then how?
But this is totally different with Descartes, the dualism. Because in Descartes, he said that mind and brain is totally different. One is a mental feature, and another is physical features.
Yes.
But in the non-reductive neurophilosophy solutions, we can say, yes, they are different, but they have a common currency. But in Descartes, they do not have a common currency. They can't communicate with each other.
Yeah, I mean, there's sort of, Descartes famously thought that they connected via the pineal gland, but there are, substance dualists or even property dualists who think that there's a way of connecting. There's a way you're going to...
Oh, okay. So in the brain, I think it's different, but it's different with Descartes interaction. I think it's different because in a non-reductive neurophilosophic solution, it's time and space, but it's different with Descartes, the interaction. I think it is different.
Okay.
No.
All right. Does anybody else have any questions at all? Anybody else want to throw in something? Going once?
Yeah. Anyone has a question?
Going twice? Okay. Oh,
So would you say that this suggests that perhaps in the future we may find out that consciousness is constituted like space? Because now we're learning that space is actually a very strange thing. You cannot cut it, you cannot fuse it. It has a lot of interesting properties that are relevant perhaps to the constitution of consciousness, if there is such a thing. So I'm just saying that it's something that I sometimes wonder about, meaning you can have a space which is constituted in a completely different way, but which still fulfills the conditions of being a space, and maybe consciousness has something to do with that. This is a bit of a strange question, but...
Okay, so, but I can more, because, for example, you stay here, your consciousness is different. If you stare outside, your consciousness is different, right? So I think the space is an important feature for the mind and also consciousness. Yeah, we can consider like this.
Okay.
Yeah.
No.
Okay.
Okay, thank you, sir. Okay, and now we have our second speaker, Cosmin Visan, introduction to self-reference. If we could please give him a quick round of applause before he starts. And then you said 20 and then 5 minutes, 5 to 10 minutes for extra. Okay, yeah, so however much time you really want to take, you take all of it if you want, but yeah, great. Oh, actually, give it to him.
Thank you for coming. I will talk about the introduction to self-reference, and I will actually offer you the solution to consciousness. So the question is, what is reality made up of? And we have the contemporary story that is made up of atoms, galaxies, cells, and brains. But actually, the reality is that the truth is that reality is made out of colors, sounds, taste, touches. So it's a totally different story. So to clarify right from the beginning, my position is idealism. It means that consciousness is all there is, and to really make things clear, brain itself doesn't exist. Brain is just an idea or a coil in consciousness. And later on, I will also bring arguments for this. So then, if we have consciousness, then what is consciousness? And I will argue for the fact that qualia are meaning. Like there is a reason for red being red, green being green, yellow and blue. So let's argue that qualia are meaning. If, let's say in the evolutionary past, if the animal was hungry and it was seeing reality like this, it will starve to death. It will not see the fruits that it needs. So in order for reality to make the animal not die, it gives it the qualia of red for the fruits and green for the leaves. And the reason being that red means important, so the animal knows that he has to go and eat the fruits, and green in order to maximally contrast with red, because red and green are opposite colors, so that the animal successfully can eat the fruits. And also in the case of the sun in the sky, there is not a coincidence that yellow and blue are opposite colors. It's the same argument that yellow means a source of light, and blue is in order for yellow to maximally contrast, so that the sun can be clearly seen in the sky. And also, people tend to say that qualia are just primary sensations, color, sounds, taste, but actually qualia are everything, including objects, people. Like in this case, the reason that we see these like bumps and these like dimples is also because in our evolutionary history, the sun was shining from above, and now if you see this disposition of shades of gray on a flat plane, we see it as bumps and this as dimples. So this is itself a qualia. Also, the duck rabbit, even though it's the same drawing on the screen, we can see it either as a duck or as a rabbit. And also here we can see if we give the meaning of duck, we also have the visual qualia of duck. And if you give the meaning of rabbit, we also have the visual qualia of a rabbit. So images themselves are meanings. And again, with Chinese characters, for people that don't know Chinese, these are just some scribbles on the screen. But for a Chinese person, this is a different experience. And even human faces themselves are qualia. The one on the left, they look okay, but if you rotate them, they don't look okay. So somehow consciousness on the left, it says, okay, let's create this qualia that look okay. And now let's investigate, because let's do some science and actually study the structure of qualia, not just say that, okay, it's just qualia. So what do you see? Oh, good answer. Other answers? Okay. 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 Yes, so I will use this example with a circular triangular because we will use it to study the structure of qualia. So yeah, initially just a semicircular and a triangle. But then we can give different meanings, and we can see a radio telescope, a space probe entering atmosphere, a parachute, an ice cream, or all the answers that you gave. So we start to see that qualia are structured on levels with the property that higher levels include and transcend lower levels. All these higher level qualia, they are not random, they inherit these shapes and then add extra meanings on top, and it creates these new experiences. And we can see also this experience inherits the shades of gray, but also adds colors, and we have a different experience. The same, this abstract shape adds the meaning of duck and rabbit, and we have a different visual experience. And yes, the additional meaning cannot be guessed. If I give you this picture and ask you what color is this, you cannot guess it. You have to add it on top to have the new experience. And let's take a more complex example from the visual domain. We can start from the black and white, and then on top of black and white we add shades of gray. And we can see that shades of gray look like black and white because it includes black and white, but also adds something new. It has something extra. Then colors, again, includes shades of gray. It looks like this green. It fluxes from dark green to white green because it includes shades of gray, but it adds something extra. So you have colors, then shapes are always made out of colors, objects are made out of shapes and add something new, and then the full visual scene. And this is the same in all the qualia domains. Like in auditory domain, when you hear a Chinese person talking, if you don't know Chinese, you hear only sounds, but if you understand Chinese, you have a different meaning. Okay, so now we have some problems that need an explanation. One is why is meaning structured on levels, and then what is meaning? So in order to explain why structure on levels, we have to consider this. A higher level includes and transcends a lower level. Both the higher and the lower levels are me. They don't exist outside of me. So in this process, I remain still me. So if I see shades of gray and then I see colored, it's still me. I don't disappear and another person appears that sees those shades of gray. So the conclusion is that I include and transcend myself. So what is the solution? Solution is self-reference. I include and transcend myself. So now let's study self-reference. First, we start with the definition. Let self-reference be the entity with the property of looking back at itself. And let's see some consequences. Because of the fact that when self-reference looks back at itself, it finds itself, then the itself that it finds inside itself is smaller than itself. Then, because of the fact that self-reference looks back at itself, it finds an itself that's smaller than itself, then this itself must be found by an itself that is larger than itself. And also self-reference is also identical to itself. So the final consequence is self-reference is smaller, larger, and unequal to itself. I know it sounds contradictory if you view it from a mathematical point of view, but that's how it is. So now we can start to understand why meaning is structured on level. So initially we can take a self-reference to be black and white. Then self-reference looks back at itself and adds shades of gray. And then self-reference identifies with the shades of gray. And then again, it looks back at itself and adds color. And then self-reference identifies with colors. And the process continues. It keeps adding level and identifying with the new levels. And that's how consciousness gets created, level by level. So now we are in the position to answer the second question. Then what is meaning? So what self-reference does when it looks back at itself is to see itself. But to see itself implies to have some kind of form, some quality. Self-reference must see itself under a certain form. And the concrete form quality is decided depending on the way it is obtained. So self-reference defines itself as meaning relative to itself as context. And let's take the first levels and see exactly how these qualities are obtained. So on the first look back at itself, self-reference meets itself for the first time. As such, it exclaims, I am. As such, the first form of consciousness is brought into existence. We obtain the self. And the quality is the sensation of being alive. If you just look at yourself, you feel like you're alive. So this is how the first meaning, the first quality is obtained. But then self-reference continues to look back at itself. And at the second look back at itself, self-reference already has an object. As such, the new meaning to which it defines itself relative to itself will take into account this new object, so it will have a different meaning. As such, self-reference acquires the new form, I am, which, because of what it means, acquires the quality of more of itself, clarity. And we can see in this example, it's the same picture, but this is less of itself, and this is more of itself. So this is as less vividness, and this is as high vividness. And the process continues. Now self-reference has two objects inside itself. You can look at either just the second one and become I am, but this is not interesting. Or you can look at both of them and then become I am, this and this, which is the self and vividness. And this gives the quality of diversity in experience because it has diversity inside itself. And as an example from higher level consciousness, this is less diverse, this is very diverse. Then it continues to look back at itself. Now it will become I am, diversity and vividness and the self. And the quality is the sensation of having lived a certain experience because it's like a memory. It remembers it was this, it remembers it was this, it remembers it was this. So that's how you obtain memory. But we have to be careful here because memory is just a quality. It doesn't mean actual memory. Memories are actually imaginary. Like your childhood never happened. You're just imagining it now in the present moment. They are just construction, like everything. Because here we can say that, okay, the chair I understand is just a picture in my consciousness. But if you really want to understand consciousness, we have to understand that everything is a construction, not just the objects that we see around, including our memories. They are just constructions that happen in the eternal present moment. And an example is deja vu. We have the sensation that we live, but it's just imaginary. And then it continues, and the next object, it will be the passage of time. And we can explain why is this obtained. So we have the quality of time itself. Then this inherits memory, so the present moment slides down into the past. Then inherits the self-reference, and the former present moment is pushed back into the present moment, and we obtain the retentional passage of time. And we can think about the music. When we hear music, if after each note the experience will disappear, it will not be music, it will be just individual sounds. So when a former note goes into the past, it's kept into the present moment, so that's how you obtain the continuity. So you obtain a passage of time, not just a succession. And now let's study some implications of this theory. We have, because the consciousness is structured on levels, we obtain also top-down influence in levels, where the higher levels exert influence on the lower levels and determine changes in their qualities. Like here, this square, we see it as blue and this as yellow, but in isolation they are gray. And the reason they become colored here is because the top level of the squares impress top-down influence in levels and colors these squares. And we can use this and also apply to time, because maybe it's not clear that time is just a quality of consciousness and doesn't exist. So if time itself is a level situated below the level of black and white, then we should expect to see some top-down influence in levels. And this is exactly what we see here. In all these three pictures, you can see is alternating black and white here, here, here. And this alternation of black and white is what creates time in these images. So the level of black and white, which is a higher level, impresses top-down influence upon the level of time, and we see motion in this picture. And this is what time is, the motion that we see. And this is some examples of self-reference keeps increasing, complex form of consciousness. And we can study it further. So self-reference is a combination of form and formless. Before the first look back at itself, self-reference is formless. After the first look back at itself, self-reference becomes form. It identifies with the self and all these other objects, like all the qualia. So self-reference is both form and formless, both at the same time. As such, we cannot analyze it using logical principle. The non-contradiction principle doesn't apply to it, because the non-contradiction principle is a principle of form, like red is different from green. Because of this, it is difficult to think about it. Correctly, we cannot speak of self-reference, because only the forms constitute objects of speech of thinking. But you know that it exists because we observe its manifestation in the structuring on levels of qualia. There is no other way to explain the levels of qualia except if we postulate self-reference. And some other implication, we will see that everything equals nothing. So self-reference never stops from looking back at itself. As such, it will produce forms at infinity. All forms are self-reference. All the consciousnesses in the world are one and the same self-reference. As such, self-reference is everything, all the objects, all the forms. Equally, it is also formless, so it is also nothing, no object, no form. As such, everything is nothing. So now you can see why idealism is the truth. So to understand why consciousness is all there is, we have to understand what existence means. So existence means to have form, to have quality, to have meaning. Like you point to red and that's what it exists. If you point to electron, it's just a theoretical concept. You cannot point to it. You only point to experience inside your consciousness. So to exist means to have form, to have quality. So as such, only qualia can exist. So as such, consciousness is all there is. Yeah, as we saw, the way the forms are produced is by self-reference to the process of looking back at itself, through which self-reference defines itself as meaning relative to itself as context. So let's see what the resulting ontology is. So self-reference can look at different objects inside itself. As such, it can evolve in different directions and give birth to different consciousnesses. But no matter how different the consciousnesses are on the higher levels, like we are individual people, they partially share in intermediary levels and totally the level of the self. So self-reference starts with the level of the self and keeps looking back at itself. And at some point, also because of free will, it starts to evolve in different directions. And in the end, you obtain an individual consciousness. But this individual consciousness, even though they appear individual, inside themselves, they are connected to different levels. So for example, this consciousness here, because it grows out of these colors, qualia, it will only see colors. It will not hear sounds. This consciousness here, because it evolves on top of the sounds, it will hear sounds, but it will not experience color. But this consciousness here, because it evolves both on top of colors and on sounds, it will experience both colors and sounds. Yeah. Oh, okay.
The volume is quite low and with your accent,
Yeah, I understand.
a little bit hard to understand, so you can slow down just a little bit.
Yeah, I have too many slides, I guess. So yeah, the question is, then what are the laws of physics? So I will give you an analogy. In the same way that money is a symbol in our consciousness that stands for the interaction between human consciousness and animal consciousnesses, the laws of physics are also a symbol in our consciousness that stands for interaction between consciousnesses that we cannot even imagine. So it's impossible for us to know what all the people in the world are doing. So in order to facilitate our interaction with all the people, we invent the symbol money and we interact with people. And similar here, there are consciousnesses in existence, not humans or animals, other consciousnesses, and they appear to us as the laws of physics. They interact and they create statistically predictable effects. And the conclusion is that I am God. So given that self-reference eternally looks back at itself, the self is eternally maintained in existence. As such, I have eternal life. Also, even though individual consciousnesses are different, they are all one and the same self. So we are all one and the same self. As such, after that, I will continue life under the form of another consciousness and so on to infinity. I will basically pass through all the lives. So what is the nature of reality? The nature of reality is God dreaming. We are all one and the same God, dreaming infinite dreams. Thank you.
Okay, thank you so much. I assume we'll have questions. Yeah, I'm going to get him at the back just because you asked the question before. All right. We have a lot of time for questions. We have 15 minutes.
Thank you. Hi, I'm Radar from Finland. I didn't hear all of your presentation, but I think it's one of the fascinating examples of things where I frequently encounter presentations here where I need to expand my mind, and I mean that. I need to expand my mind. So thank you for helping me stretch my brain here as well. I just have one simple question at this stage. If this is your worldview, how does that influence your daily life and when you're among all of us here and at a conference or going through your life? What implications does this have for you?
I think the best implication is in the past, for example, I was fearing death. And now that I know that I have eternal life, I don't fear death anymore and I just live life. Also, there is a problem with like meaning of life. When you are young, you say, oh, I'm wasting time, I'm playing games on the computer or something, so I have to do something important. But when I understand that the purpose of existence is simply to have experiences, then all experiences are equal. So you don't have to worry, today I'm not working or something. You just do everything because the purpose of God is to know everything that He can be. So any experience is equally important.
Thank you for the talk. It was really interesting. I wanted to ask, how does your framework explain like problems of qualia inversion? So why isn't the sky and the sun green and red as opposed to blue and yellow?
Yes, because the qualia are not arbitrary. They are specific meanings. Like for example, you look at this chair and you see it as a chair because it has a specific meaning. And the same, the purpose of yellow is yellow means a source of light. So the sun has to be yellow and the sky has to be blue in order to contrast. You cannot invert it.
But do I and like every consciousness give this meaning, or is it like predetermined in some way?
Well, I think it's predetermined because we are the same species and we function identically. But of course, you can have injuries, I don't know, to the brain, even though the brain doesn't exist, and it might affect perception. But qualia themselves are a specific meaning, and they cannot be inverted.
Okay, thank you.
I'm just going to work my way up slowly.
Hi, thank you for the talk. My question is about the levels of consciousnesses. And starting from you talk about self-referencing. Obviously, humans have an idea of self, but I don't know when evolutionary do organisms start having the idea of self. Obviously, a lot of them don't. So do you have to have the idea of self to do the self-reference, or even rocks and birds and like plants can do that? And in addition to that, can I evolve my consciousness? You said the only purpose of life is to have experiences, but there are obviously higher level of consciousness in your theory, and can I work towards that, and should I or not? Thank you.
First of all, we have to make the distinction between self and ego. We humans, we have ego, and you can say that plants, maybe they don't have ego, but the self is one and the same. The self is the sensation of being alive, and even a plant, I don't know, unicellular organism feels alive. So that is the self. So we are all that self. And yeah, you can evolve consciousness through different methods. I guess this is one of the purposes of life.
Really quick follow-up. When you use words like organism and cells and the sun, these all sound like physical objects. That are affecting a system, but they are not, right?
No, they are not.
Yeah, right. But they're qualities distinct from the system. Can you just quickly clarify that? Are they just qualities affecting another quality affecting some quality?
So, like an example with money, qualities are tools that we use in order to interact with the larger realities of other consciousnesses. So we might see a sun, but behind the image of the sun, there are other consciousnesses. Doing their things there. Okay. Not the sun as a physical object, behind the image that we see as the sun.
Right.
So there are consciousnesses doing their things, and then we give meaning. Okay, you are sun, you are chair, you are, but we have no idea what is there.
Sure. Okay, so I've been on this side. I'm going to try to go to the right here. Does anybody have questions here? And then I can come back to the left. Just want to make sure we get everybody.
Thanks for that talk. Right. So your theory of the self-reference involves the infinite, regress, right? Or I could say like a circular thinking. Am I correct? Right.
Not really. In what way circular regress?
Infinite regress means like knowing of knowing, or looking at, looking of looking. Just keep looking at the, things all the time, going like this.
This is one way you can do it, like rationally, but it also happens automatically. Like when you look at this chair, self-reference already constructed. It starts with black and white, it adds shape, it adds color, and you just see it.
Okay, but so let me talk about this in my context, right? So, so it seems like the consciousness itself, stops, the circulation, kind of automatically within, right? But in my experience, let's say, knowing of knowing, looking at something, keep looking at it, I cannot stop it, consciously. But, what stops it is always like an environment, hungry, or, like a big sound out of it, or like going bathroom, something like that. So my question is that, what's the very subject which stops that circulation or, infinite regress, in the context of my, question?
Yeah, it's a good question. One way, as I see it, so it constructs this chair, it constructs the objects, but then we continue to live life. If we change the view from the chair to the table, then it continues to create objects. So I think in this way we can view it. You cannot stop it. Life goes on.
Right. So keep going all the time.
Yeah.
All the time.
Yeah.
Oh, okay.
And after that, it will keep going and invent new lives.
So that's the reality in your context.
Yes.
Okay. Thank you.
Thank you. So I'm a neurophenomenologist researching advanced meditation. And I may understand your construct slightly wrong, but self-reference in neuroscience, right, is like you have a narrative self or something thinking about yourself. And in advanced meditation, you usually see that in advanced meditative states, if self-reference dies down, sensory clarity, for instance, increases. And this is actually opposed to what you showed earlier in the slides. Also, there are states like Nirodha Samapatti, for instance, where somebody has, over an extended period, no experience, and then they come out. How do you think of that? Like, that somebody literally has no experience, and then an hour and a half passed, and they come back. Yeah. Do you have any thoughts on that?
Yeah, I'm not sure. I'm not familiar with meditation. I don't do.
Thank you for your talk. Excuse me. I think you talked about it, but maybe I would like a little bit more clarity. I didn't quite grasp it. But what's the relationship, or how do you conceive the relationship between the self and the other?
What do you mean? So we are at the
Where are other people?
At the foundation, we are all one and the same self. And then self-reference evolves in different directions, and it creates individual consciousnesses. So we are individuals, but we share intermediary levels, or totally the level of the self. And also, like in cases of telepathy, you can connect with other people. You can unify some of the intermediary levels.
I'm just thinking, because you mentioned like all experience sort of is equal, which reminds me of Jorge Luis Borges in his literature, but it doesn't really feel like that to me.
Yes,
there are experiences that I avoid and others that I seek.
Yes, because they have different meanings. Like pain is it means something bad for
outcomes.
You. Yes. They are equal in the sense of knowledge. In order to, if you know pain and if you know pleasure, for self-reference, for God, let's say. From this point of view, they are equal, but from the qualitative point of view, of course, pain is to be avoided and pleasure to be seek.
Okay.
Did I miss anybody back here? Yes. Would you like to? Okay.
What is the role
Matter is what the other consciousnesses are doing and their behavior, because let's say maybe they are primitive consciousnesses and they behave regularly. And we, in our own consciousness, we project that behavior and we see it as the laws of physics. Like the border of a country, you cannot pass through walls for the same reason that you cannot easily go to North Korea or something.
Yes. We probably have time for maybe one more question after this.
Thanks. Is one of the premises of your framework the following? Self-reference requires consciousness?
The self-reference produces consciousness.
Yeah.
When it looks back at itself and it finds itself as a meaning, then that is a form of consciousness. The qualia that I mean, what you see around you, it's self-reference in action. That's how it looks like.
We probably have time for one, actually maybe two questions. Anybody else have any questions? Oh, yes.
I just wanted, it reminds me a little bit of the binary constructions where you start, the empty set is the I.
Yes, exactly, yes.
The one is
yeah.
the empty set looking at itself.
Yes.
And then you can construct all the...
Yes, like von Neumann construction of cells.
Any other questions that we have? Any other questions? Okay, really quick, one question. If we're all somehow connected,
Yes.
is that we sort of all kind of branch off in different ways? That's what gives us each our own individual consciousness.
Yes.
But does that mean I could still access other consciousness? And is it possible for me to, for example, access your consciousness because technically we're somehow connected?
Yes, of course. And empirically we know there is telepathy. But exactly what connects to people, I'm not sure.
Could I understand your mind directly? Could I access your mind?
If you were to access my mind directly, like completely, you will not feel like you are accessing my mind. You will feel like you are accessing your mind because there is the same self. Like, let's say you access my memories. And you will not say, this person lived in that country. You will feel like, I lived in that country, but I forgot and now I remember.
I see.
It will feel like it's your memory because
I
it's
see.
you.
So I'm always sort of tainting it from my perspective. Okay, fair enough. All right, any other questions at all? Yeah. Oh, we do have a couple. All right. Sorry, I didn't see these hands. Ask one, then can you please pass it back after you get there?
Do you think that there could be some crypto system in between so that the other part is hidden or safe for access? Not accessible. Could you imagine that there's a kind of crypto system, like a safety process running that no access, like he asked, can manipulate you for your negative purposes or whatever?
Yeah, it all depends on how self-reference exactly is organized. Because this is the theoretical framework, but in practice we have to do empirical science to know exactly how it got organized.
So,
Yeah, maybe I missed, but why am I not accessing other people's thoughts or memories? Like, why do I feel like I
I'm not
can't
sure,
access them?
but for example, in cases of love, those people start to have telepathy and access their minds. Like also precognition, if a loved person dies, you somehow know in advance. So I don't know exactly what are the mechanisms that connect people more deeply than this.
But if we are all the same mind, then in principle we should be able to access.
We are on the internal levels, but on the higher levels we differentiate from one another.
Okay.
Any other questions? Any other questions? Yes. Probably will be our last one.
Thanks. Spirituality seems to concern the feeling of separateness versus not of individual consciousnesses. Can you say anything about how that feeling of separateness comes about after an individual consciousness is there?
You mean why do we feel separate?
Yeah. I guess some consciousness don't feel separate, but most people feel separate. But then they have spiritual experiences and they recognize they're not separate. So what's going on
I guess
there
in the
this
spiritual experience they access the level of the self. And it's just one and it feels like connected with everyone. but I don't think it's actual connection. I don't think you can read minds. I'm not sure.
Yeah, I guess I think at the core of spirituality is this, the overcoming of a sense of separation, basically.
Yeah, I think we access the level of the self directly, and we realize that we are that one self that is in all of us. I think this is what happens. I'm not sure. I don't do such practices.
But why do we think that we're separate in the first place? Where do we get that sense of feeling separate?
Because self-reference evolves in different directions, and then it gets different qualities for each one of us.
Okay. All right.
Yeah.
Great. If we could please give a round of applause to Cosmin Visan.
Thank you.
And we now have our next talk from Uzi Awret, and he's going to be talking about brain coherence and the loss of which-way information. Please give a quick round of applause before he starts. Escape this. And let's go and close that out. Just going to not save anything here, any changes. And then this is yours, and then we'll go ahead and get it started. Oh, no, this is not yours? Oh, no, this is the last one.
It's not a bad one, but
yeah, it's the last. Sorry, it's the last one.
maybe I'll take it.
Yeah, sure. This is yours, right. I'm going to go ahead and get the slideshow started. And great. Comfortable to click on everything?
Thank you. Okay, so what I want to talk about today is, it's not exactly a philosophical subject, but they put me in this section. So, and that has to do with can the brain's complexity generate entanglement? And the idea is that, you know, if you think that there's some kind of special physics to the brain or something, then that physics has to somehow have to do something with the special characteristics of the brain. If we ask ourselves, what is the most amazing thing about the brain, or the most special thing about the brain, or something, then you'd have to say that it is its enormous hierarchically nested complexity. And the question is, how can you leverage that tremendous complexity into some kind of principle that can be philosophically significant? And what I'm interested in is, can complexity somehow generate entanglement? And okay, so let me. So the roadmap is can the brain's complexity induce entanglement? I'm going to start with the ignorance hypothesis and missing non-standard physical facts. This is by Daniel Stoljar. I'm going to mention that we're during a scientific revolution. This is when these non-standard facts sometimes appear. And I'm going to then explain something called loss of which-way information and how it's related to entanglement in quantum mechanics. And then I'll try to relate loss of which-way information to the brain to ask whether that can somehow generate entanglement. So I just want to start with the LLM consciousness, which reminds me of the cargo cult plane. So I'm going to quote Feynman. So Feynman would plane cargo cults. They're doing everything right. The form is perfect. It looks exactly the way it looked before. But it doesn't work. So I call these things cargo cult science because they follow all the apparent percepts and forms of scientific investigation, but they're missing something essential. And this is when American cargo planes were landing in the Second World War in the Pacific. And the locals worshipped them. They thought that they were gods or something, and they always wanted them to come back. But then they wanted to recreate it. And so they were sitting there, but nothing happened. So with the LLM consciousness, it reminds me a little bit of that. So, but that is because my position is completely different. My personal inclination has more to do with, I think that the reason we have these anti-physicalist problem intuitions about consciousness has more to do with some unknown physical principle, meaning we don't know enough physics. And so I'm a bit of a type C physicalist, people who remember this classification, meaning that somehow the explanatory gap can be bridged by physics, but we still don't have all the physics. Okay, so are we missing something? According to Stoljar, the most likely explanation of our anti-physicalist problem intuitions is our ignorance of relevant non-standard physical facts. Stoljar's weak non-standard physical facts are non-phenomenal physical facts that can be related to an important class of scientific revolutions that result from sciences that mature to the point of producing novel determinations of their own scope and limitations. I will explain. From the inside, so to speak, minimizing unnecessary metaphysical commitments. So quantum indeterminacy and arithmetic undecidability are examples of such maturation, meaning Heisenberg's indeterminacy was discovered from the inside by classical mechanics, and you had the birth of quantum mechanics, but it's not something that a philosopher was likely to discover. So when we learn really interesting things about the world, usually they come from sciences that reach a certain point of maturation where they begin actually to explore the scope and limitation, their own scope and limitation, okay? What's possible, what's not possible. And the same thing, let's say, with Gödel's incompleteness, where you can actually use arithmetic to discover its own scope and limitations. Again, it's not something that a philosopher was likely to discover. It's much more interesting. You can see already that I'm a bit of a naturalist. Stoljar's facts must be standard enough to count as physical and non-standard enough to make a philosophical difference. So how does the brain view itself? Depends on the technology available to it. I'm not going to get into it too much, but here's just a quick history. Elan Vital and Numa, and then you had the ancient brain that was a ventricular brain with little ventricles, and Numa that flowed in between the ventricles, a bit like a pneumatic railway or a pneumatic library or a pneumatic Baroque brain. You know, I'm using the computer sometimes to generate nice pictures. But then we moved on to a more electric brain. The frog legs responds to electric current. Electric switchboard brain, electronic digital brain, deep recursive neural networks, and what I want to talk about is a massively entangled quantum brain. How can a brain become massively entangled? And I have a completely new proposal. It's a bit speculative, but still it's different, so I think it's interesting. Okay, so are we missing a simple physical fact or principle commensurate with our core physical theory whose knowledge could defend physicalism from the conceivability and knowledge arguments? And what's the best place to look for non-standard physical fact like the ones that Stoll just mentioned? And you can wait for them and wait for a scientific revolution. That's kind of a messianic naturalism. I hope it's going to happen. And especially these revolutions can produce especially radical discoveries. Just for an example, the local robustness of space is dual to the non-local quantum error correction code. This is just an example of certain radical discoveries. The question, of course, are they relevant to what we're looking for? And the question I want to ask is, has this complexity revolution matured to the point of producing results about its own scope and limitations? Meaning, this would be interesting, I think, and especially because we're in the midst of a scientific revolution that brings together quantum field theory, condensed matter theory, which is a really sophisticated form of quantum field theory, quantum complexity, quantum computation, computational complexity, black hole thermodynamics, massively entangled many-particle systems, exotic phases of matter, profound dualities, and even hydrodynamics. And all of these are beginning to become a bit connected with some new ways of thinking, like the holographic principle. So we're also entering a new domain of gigantic Hilbert spaces, and so 1 gram of entangled atoms generate 10 to the power of 10 to the 23 dimensional space, and this is what John Preskill calls the Wild West. So we're entering this new domain of massively entangled particles. We're just beginning to explore it, and we're discovering some very interesting things. And first here, entanglement is viewed as a resource, not as a nuisance. Information is more fundamental than space-time, which itself can be derived from properly entangled qubits. So discovering that the brain's physical correlates of consciousness are massively and conformally entangled should provide us with a significant philosophical advantage. I'm not going to get into it right now, okay? Because I really want to talk about how you can get the brain to be massively entangled. You can ask me later if you want. And there are many quantum brain theories that aim to relate aspects of consciousness to quantum processes in the brain. Quantum brain theories must explain how large-scale macroscopic entanglement can persist in the warm brain for biologically relevant duration. It's like a biological quantum supremacy. And there are different attempts to explain such large-scale entanglement. The entanglement has to be macroscopic. From dipole-dipole interactions and between aromatic molecules to entanglement between cage-free radicals to, I don't know, entanglement through the structure of space and more. So it's fair to say that these are problematic, and it's worth also searching for some new idea which is maybe simpler, maybe a bit controversial, but it can give you a lot. So sometimes it's nice to look for such ideas. So I'm going to use the top-down approach. Consciousness is a unique physical phenomena. Brain is a unique physical system. The two are exquisitely correlated. The brain is unique because of its large hierarchical complexity. Find a simple new principle that relates such putative massive brain entanglement directly to its unique complexity. And this is really what I want to do. And the putative simple that I want to suggest, extend the principle of loss of which-way information, which I'm going to explain, which is central to coherence in quantum mechanics. There's a Hanbury, Brown, and Twist, people who know this experiment. And also entanglement in quantum optics, delayed choice experiment, quantum eraser, and all the way to complex, hierarchically nested, many particle systems. So what do I mean by loss of which-way information? Let's say that I'm a detector, and there are two atoms at the other side of the room, and the atoms are very close to each other. Let's say the distance between them is delta x. Then here at the detector, if they're so close that you cannot tell, if the detector clicks, and you're not sure which one of these two excited atoms has de-excited, then it seems like they came from a coherent source. And this is a very strange phenomenon, because again, if you separate them, delta x becomes big enough, then this coherence disappears. But if you have loss of which way information, that is, you don't know if you came this way or that way, the detector clicks, and let's say that you do it many times, what you're going to record is just something that came from a coherent source, as if the two atoms were entangled or something. And, but this is a principle that is known in quantum optics. And the question is whether I can use this principle of loss of which-way information in the brain, because the brain's enormous complexity may enable something like this to happen, and I'm going to talk about it. Let me just describe loss of which-way information. So you can see here, for example, you have a photon. The photon hits a half-silvered mirror, and it can either go straight and up, you see the blue path, or it can go this way, hit the mirror, and then go through the red path. And if you shoot a lot of photons like this, basically you're going to 50% are going to go up, and 50% are going to be horizontal, meaning both red and blue are going to exist. By the way, every time that this happens, you have a shift in the wavelength of half a wavelength. And because of this, if you insert another mirror here, what happens is that the one that say this one reflects twice, so nothing happens to it, but the other one reflects only with half a wavelength. And the point is then that one of them interferes destructively and disappears, and all the photons only go in the right direction where they interfere constructively. But if you ask when does it happen, it only happens when you, so I'm saying this can exist on another planet, and it's only when you put the half-silvered mirror in that this phenomena happens. So you can say that it is the loss of which-way information. As long as you have a loss of which-way information, you're going to get this entanglement. And it's not something that happens here in the beginning. Here, this is a delayed choice quantum erasure. I'm not going to get too much into it, but also it is a very nice example of, here you actually have an 8 nanosecond delay, and then you have a restoration of loss of which-way information, which restores the entanglement. And, okay, so the loss of which-way information then results in entanglement. Restoration of which-way information destroys entanglement. Restoration of loss of which-way information restores entanglement. Okay, that one destroys entanglement. Okay, so the question is again, what does, how can we use the brain for something like this? So the conjecture that I'm kind of curious about is whether loss of which, okay, so loss of which way information conjecture is sometimes theoretically impossible to determine the causal firing history that results in the firing of a given neuron. So imagine that a neuron gets a bunch of signals and you cannot really tell what the causal history was, meaning which really ones of the signal caused the neuron to fire. Then in such a case, you would have a loss of which way information, then maybe that would force an interesting relationship on the different causal histories. Okay, so this may cause the input to the neuron to seem coherent, meaning if there are a lot of parallel causal histories that are indistinguishable, then all of these should be considered, and then these are the ones that would become coherent. Such neurons can create clusters in which all members of a cluster receive input in small enough windows to generate loss of which way information. Now I'm going to explain that a little further. And this novel kind of loss of which way information generation may somehow be related to a complexity-based theoretical bound on preservation of which way information that is surpassed by the large hierarchically nested complexity of the brain. Here, I don't want to get into this. This is just an example of hierarchically nested LW loss of which way information, and disregard the details. But the point is then that you can have at each point you can have a loss of which way information, and under certain conditions it would actually cohere the system. So let's start with spontaneous small world networks. So suppose that you begin with a large randomly interconnected collection of neurons, and you gradually raise the membrane potential so neurons begin to fire, and assume that the firing is stochastic, but that the arrival of a small number of inputs in a small time window has a higher firing probability than the arrival of a large number of signals in a larger time window. This can result in tight small world recurrent networks of neurons that kind of self-choose to get their input in increasingly smaller time windows. A bit like vertices, meaning where you can have energy that is distributed along a bigger area, and eventually the system localizes the energy to prevent large-scale disturbance. It's a bit like the Chatelier principle. Anyway, so such sparse small networks form, I can argue, form an efficient NCC. I'll explain. And they explain Rafi Malach's results showing that consciousness persists up to 2 seconds after reverberation is stopped. So people thought the consciousness was associated with reverberation, especially in global workspace theory. But it turns out that after reverberation ceases, consciousness continues. And perhaps the only way to explain it is by very small, tight networks that are harder to discover. So sparse small networks that are harder to detect, so this is just an example, it's a drawing, but you can see the smaller, and it's a bit of a small neighborhood architecture. And maybe this is where everything happens. And of course, all of these have extremely small time windows, so that maybe they get a small number of inputs and they arrive together and they're somehow coherent or entangled. So this is a cluster of tight neurons with small windows, just an example. Now, this could result from evolutionary pressure. So you had the Hebbian rule: neurons who fire together wire together, and those who fire out of sync lose their link. You also have a spike timing dependent plasticity, which further decreases the size of the window, meaning that it tightens things because the presynaptic signals arriving immediately before postsynaptic firing are strengthened. And it's like molecular coincidence detection, but this actually decreases the size of the window. So is it possible that evolutionary pressure shrunk these windows to the point of generating loss of which way information? And if this happens, and you get loss of which way information in every neuron that belongs to a certain cluster, then things begin to be interesting, and you can get a new kind of large-scale entanglement that is based on complexity. So has this mad evolutionary race crossed a biomimetic boundary on complexity that we still don't understand? Is it possible that consciousness is an unintended consequence of the increasing complexity of the brain? Now, recurrent processing can cause, so it's like you have a loss of which-way information in the loop. It could conceivably cause the neurons in the cluster to generate a novel type of loss of self-information, meaning that now if you have loss of which-way information in which the neuron itself, so the neuron doesn't know if it participated in the causal history of its own firing, this can create a very interesting situation. I know that Rafi Malach likes this. We talked about it. He kind of, he likes the idea. Anyway, so this is reminiscent of Seth Floyd quantum circuit where teleportation plus post-selection generates self-consistency conditions that are similar to a closed CTC, which is it's like a time loop, okay? And this can only happen for qubits, but let's not get into that too much. And so another, okay. So basically, I'm almost finished. We talked about recurrency. There's just one more point, and that is, for example, that if let's say in IIT, you have in integrated information theory. Okay, in integrated information theory, you have a sum of all the causal histories as part of the calculation of phi, for example, if I remember correctly. And here, in a way, all the sum of all the indistinguishable causal histories, so you have a lot of indistinguishable causal histories, this is the whole idea, and then you can say that the sum of those, the indistinguishable causal histories, this is really the sum that matters because these are the ones that become coherent or become entangled. This is it's a bit similar to Richard Feynman's causal history formulation of quantum mechanics, where it's the ones that are the classical ones that in a way survive. But so this is just a different way, perhaps, of approaching. Again, it's a bit speculative, but I think the idea that somehow the complexity, the enormous complexity of the brain, could definitely have something to do with the strange physics of the brain, and that may well have to do with certain forms of large-scale entanglement. If not, if the brain is completely classical, then we would miss a lot of very interesting physics that we're getting into right now, and that is not likely, I think. But yeah, this is basically what I wanted to say. Okay.
Actually, you can hold that. All right. We've got about 8 minutes for questions. Let's see. We'll start here, then we'll move over to this side.
Thank you very much, Azil. You packed a lot of really interesting stuff in there, and I'm not sure I understood it all, but it seems to me that there are two approaches. There's a fork in the road in consciousness theories. On the integrated information road, or even the global neuronal workspace theory, there's the idea of classical complexity bringing information together in one way or another. And then there's the other fork in the road, which is the appeal to quantum mechanics, entanglement, loss of one-way information in your idea, in some way bringing information together in a slightly weird, difficult to understand way. And they seem to be completely different approaches. And what I wasn't clear about is how in your model you need such a complex structure as the brain to produce your loss of one-way information, because it seems that it can be produced from quite simple structures like the quantum double eraser.
No, absolutely, but there, the experimental setup there is completely different, and so you talk about, let's say, like the example that I gave with one photon or two excited atoms and one detector, but what I'm trying to do is use the enormous complexity of the brain. Remember, you can have all it's enormous complexity with trillions of connections, and that is without the dendritic network. Today they were talking about the apical pyramidal neurons from layer 5, for example, and Carl Prybram's who actually talked about the dendrodendritic networks, and this is another enormous layer of complexity. And all I'm saying is that what happens here is that you can have a bunch of histories that are indistinguishable. So if a neuron suddenly fires, and there are a lot of different possible histories that could have resulted in this firing, and if, let's say, millions, and out of these maybe a couple of thousands are indistinguishable because the timing is actually makes it possible, then it's exactly the indistinguishable histories that will really matter and become coherent or entangled. And now you can actually move on to use this for, I have my own theory, and I'm not going to get into this now, but just the question of how can you get the brain massively entangled, especially the relevant parts of the brain, and this just gives you a simple solution. Of course, it is a bit strange, and like you say, but sometimes you get so much out of it that it's worth considering. If you know another way of somehow leveraging the complexity of the brain to get something, I'd love to hear it. Yeah.
Okay. Thanks for your lecture. So you mentioned about the quantum brain. So you mean these quantum effects in our brain, right? The quantum effects like quantum entanglement, quantum superposition in our brain, right? So do you believe that is quantum consciousness happening in our human brain? Yeah.
Okay, this is exactly the part I didn't talk about, because this was just about how can we generate massive entanglement in the brain, and why we would actually entangle the right parts, the parts that matter. But what the next step that I would do is once you have a massively conformally entangled system, it has an ADS dual, okay, an anti-de Sitter space dual, which is a real space. And this space, by the way, is interesting for what you were thinking about with how do I use space to connect between the mind and the body, or between mind and matter, right? And you yourself said that space may be the way to negotiate these two things, right? And here, if you manage, if all I'm saying is true, which I don't know if there's a big chance for that, but if it were true, then you probably would have a dual ADS space, and that actually is a very interesting space, and it is finite from without, infinite from within. It has all kinds of interesting properties, and it does explain certain things about how space can negotiate between mind and body. But okay.
Okay. In your first point, there's a recurrent processing loop system.
Yeah.
Such system can have limit cycles. Did you consider something like that?
I haven't thought about it, but because the question is how much recurrency you have in the loop.
And the next question would be, wouldn't be limit cycle more natural than no limit cycle in a brain that oscillates, that regenerates, or whatever?
It could be,
And would a limit cycle system make another relation to the information loss problem? Because some cycle could clear your question, and yet it does not matter anymore as thinking without cycle. This is my question.
Okay, I haven't thought about it. It's possible that the limit cycle would be a solution. So, for example, this may interest someone like Victor Lamé, who does recurrent processing theory. But here, I just mentioned it to describe, first of all, when you do have recurrent processing like this with a bunch of tight neurons, meaning that they all get their inputs through very small time windows, then I was just wrong about the possibility that a neuron may participate in its own indistinguishable causal history. And this is just a strange situation. There's something I didn't talk about if you're a physicist, where I can use the quantum erasure. And the quantum erasure experiment, I can take, let's say, 7 or 8 of them, connect them in a loop. And then there was a delay time of 8 nanoseconds where things were kind of undetermined within one system. And if the time it takes to travel the loop is smaller than 8 nanoseconds, then now the whole thing is in a very strange state of matter, you could say. So there's just all kinds of possibilities, but the question is whether this thing holds water.
Yes.
You know?
And then we come back to your beginning. Maybe some rules are not obvious.
Yeah, this is. I'm saying as a type C physicalist, this is my yeah.
Great. If we could please give our speaker one more round of applause. And, I'll take it. And do you have your slideshow on?
Yeah, it's in there. It's,
Okay, great. You want to go and pull that up, and then after you pull it up, I'll introduce you. Great. We have here Andre LeBlanc, who's going to be giving a talk titled Joseph Delboeuf and William James on the problem of free will. Please give a round of applause to our next speaker, and then you can start.
Thank you very much. Thank you for organizing this, and the volunteers and the chair. I also want to thank my university for paying my trip and to Barcelona. I'm going to be referring to letters from the William James collection at Harvard University, so I should thank the librarians for giving me the permission to cite them. Just a little bit. I'll just be citing a little bit. So this project that I'm working on, it's a paper that I'm writing on William James and Joseph Delboeuf. And both of them were early pioneers of psychology. I think everyone in this room, pretty much, except for some family members, have heard of William James. But Joseph Delboeuf, maybe a little less. And I consider myself a Delboefian scholar, maybe even the world's leading Delboefian scholar. That's because I'm the only one, but anyway. So, anyway, you'll see his ideas are very interesting. He was, as you can see, early pioneer in psychology. Free will was important to both James and Delboeuf. Now, the main difference, and that I'm going to argue, and I hope to develop in my paper, is that James approached free will mainly, at least in comparison to Delboeuf, as a philosophical problem. But Delboeuf really wanted to treat it as a scientific problem. Okay, so a little bit about William James. He's born in a wealthy Bostonian family, got his medical degree from Harvard. Harvard professor, he taught philosophy and psychology, physiology as well. And some of his famous books, a lot of you are familiar with them, Principles of Psychology, Varieties of Religious Experience. James's interest in free will begins quite early. This is well known. He had he was sort of susceptible to depression all his life, but he was a lot better later. But when he was young, very difficult, depressive times. Maybe he wasn't too sure what to do with his life too. That contributed to it. And one of his worries, fundamental worry, was that maybe we're determined. As science is developing, and we're learning about the laws of nature and all these principles, and it looks like, hey, we're made of matter. Matter seems to obey these laws in a deterministic way, so maybe we're determined as well. And in a letter, he said, he's worried that we're nature through and through to one of his friends. And therefore, maybe we don't have no free will. And it's something that really bothered him and frightened him. And now one of the things that saved him was Renouvier, Charles Renouvier, a French philosopher, who was a defender of free will. And this is very, very well known. So James, reading this philosopher, it helped him to overcome his depression. And we have this well-known diary entry where he says, my first act of free will shall be to believe in free will. That's his first act, right? So, now this is going to be important, his whole approach, and we're going to see this sort of same argument throughout his life. Now, here's the, now I'm going to use this example to explain. For him, it's a matter of belief, okay? So, and why it's a matter of belief. So, suppose we resist the temptation to eat a second slice of pecan pie, which I did not last night. Now, I don't want to spoil it for any of you today. Just if you want 2 slices of dessert, go for it, okay? And, now, suppose I resist the temptation. Then I really want that pie, but I'm not going to do it. And then I feel proud of myself. I didn't take that pie, you know, I'm going to... I don't know where that's coming from. It's not from my playlist. Maybe we could cut the sound. No, eh? Okay. Weird. Okay, good.
Okay, I guess we're just going to get back into it.
Yes. So this is something that James points out in 1880 in a paper called The Feeling of Effort, that we feel our freedom the most keenly when we take the path of most resistance there, as I put there. So he gives also, I'll come back to this, but he gives an example of an alcoholic who, you know, if they avoid, a drunkard, he says, avoids going into a bar, they could feel proud that it's like they overcame their urge, their temptation to go into the bar. But if they go into the bar and they say, well, I overcame my impulse for sobriety, you know, that's why I went. You know, we don't really believe that, you know. We feel like there's a difference, you know. Why did you go? You know, like you caved in to your urge. So Delbœuf will really like that distinction. Now, here's the problem. Now, suppose I resist the temptation to take a second slice of pecan pie, and then I could say, there, I exercised my free will. But a determinist could say, well, maybe the impulse, you know, to lose weight was stronger than your impulse to eat the pie, and that's why you didn't. You know, you're still determined by your motives, by your impulses, by your urges. That's what bothered James. So he would say there's no empirical way of deciding. We can't decide. That's his position. Now, there's a link with his pragmatism. So we start with the assumption that we can't resolve the debate between free will and determinism. And for him, it's a question of belief. He'll use the same kind of arguments for people who may want to, like, believe in God, for example. Same kind of idea. Now, his argument is that, you know, look, it helped me. It helped James, you know, to believe in free will. It made him happy, got him out of his funk. And, but it also makes psychological sense. It helps us understand, you know, when the drunkard goes into the bar, why we feel that he's not taking the path of most resistance. He's not actually being free. And And he gives other reasons, but I don't have time to get into them. Okay. Now, that's going to be his general argument in all his writings on free will. The main ones are here, as you can see, over this 10-year stretch. So the debate is insoluble. We choose to believe because it's pragmatically beneficial. But it's a matter of belief. But it works, according to James. Now, Joseph Delbœuf. Delbœuf was 10 years older than James. He's born into a very poor family, and his father was sick, and they didn't have enough money to send him to school until the age of 9. And then his father got sick, and at the age of 14, he starts supporting his family he goes to school, and he quickly goes to the top of the class. And then he had to support his sick father. He dies when he's 16, then he supports his mom. And he's doing this by giving lessons to other kids, like he's tutoring other kids. And then he pays his way through university this way, and he earns a PhD in philosophy, and then another one in physics and mathematics. He'll be a professor at the University de Liège. Now, there's been a kind of like a revival of interest in Delbœuf in the past 30 years. And I'm one of a handful of people who are doing this. And they've argued that his ideas were so interesting that they're still relevant today in psychophysics, hypnosis, evolution, and consciousness, non-Euclidean geometry, so he published in geometry, mathematics. Bertrand Russell cites him, Poincaré, Mach, they cite him. And then, of course, free will. Now, so Delbœuf's approach, what he wants to deal with is the problem of the law of conservation of energy. It's a scientific argument against free will. Now, the law of conservation of energy is pretty much established by 1848. That's when Helmholtz would publish his famous paper. And the law of conservation of energy implies determinism. As you can see here, it's the idea now I've got props, so I'm just going to grab my prop. So I couldn't get billiard balls, so I got my second best choice. These are authentic pétanque balls from France. When they go like that. And now the idea, and many realize this, it's not just, there's James Maxwell. He was struggling with this problem that conservation of energy poses for free will, and others too. So the idea is that everything moves only when something else comes into contact with it, or some force influences it. So this ball, you can just imagine it's like on a table or something, and it's not going to move unless something hits it. If we have free will, we need to be able to influence the course of nature. We have to make this move now. It's not going to move. Now, if we made it move, if it's a molecule in my brain, and I make it move through my mind, my will, then that will add energy to the universe. It'll be an effect, but no cause, right? The effect without a cause. And so it's not going to move unless something else comes and hits it. It hits it, transfers its motion to it, then moves. And now, if it hits it, it's going to go that way. If you hit it and you make it go this way with your will, then you're violating the conservation of energy. The force should go in that direction, but you'd be adding a force from out here, and that violates conservation of energy. So it's a huge problem for those who believe in free will. How can you influence the course of nature without violating that law? And Delbœuf is going to come up with a solution. Oh yeah. So anyway, Maxwell thought that maybe, because of this, it can't be the power of the wind. It maybe what the will does. It's like the rudder of the sailboat, and or maybe it's not like the power of the change. We can't initiate action, but maybe we can direct it, like shunting trains from one track to another. Maybe we could do that. And call it a directive principle. You just a really small push. Maybe it's too small to measure. That was his kind of way out of it. But the problem is that even a small push will require energy. A small push that will just make the tracks go left to right. Okay, so they were struggling with this. It's still a problem today. Now, Delbœuf's solution, and this is one of the most amazing ideas I've ever encountered. So we have this ball here. This one comes along, this molecule comes, hits it. It has a certain momentum, but suppose it transfers all its momentum to this ball, so it's going to stay there stationary, this one's going to move. Then how can we influence this interaction without violating the conservation of energy? And Delbœuf proposed, suppose, okay, the ball here is here, this one comes, hits it. Now it's going to transfer its motion. It takes there's always an inertial delay, and it's going to transfer its motion, but what if we could just hold it there for a few moments? Let's just hold it there, and then let it go. And then when it goes, it's got to go with the correct momentum. If we could influence the time that the interaction takes, okay, the time of the transfer of motion, if we could, we could quicken it or prolong it. We could influence the course of nature without violating the laws of thermodynamics, the first law, conservation of energy. If we could influence the duration of the interaction, and as I point out here, time does not figure in the equations of thermodynamics. It doesn't matter how long it takes, as long as the energy going in is the same as the energy going out. But time doesn't figure in there. So he's proposing time as time, at least prolonging the inertial delay that's inherent in all interactions. So the idea is that, like, when we resist an urge or an impulse, it's something like two molecules interacting in our brains, and I'm not going to go and take that second piece of pecan pie, and I'm going to regret what I just said, but you know, we feel the urges, and then I'm not going to act on that urge. And he liked to cite James on this: we feel our freedom most keenly when we take the path of most resistance. And it's consistent with Benjamin Libet's concept of free won't. I'm sure many of you have heard of it. I'm not going to say any more about it because our next speaker is going to be talking about Libet and John Searle. So that saves me a lot of time. Now, an important point is Delbœuf is suggesting a testable hypothesis. I mean, if he's right, we will see this. We will see it, suppose, in our own brains. When you exercise your will, when you decide to move my arm, and then we can look in the brain to see where I did this, where it's happening. And all the other interactions are happening normally, but there, at that point, you'll see a difference in the timing of the event. That's the prediction. There's billions of interactions going on, and just there, where you exercise your free will, you're influencing the course of nature, we will see that delay. If we don't see the delay, then he's wrong. Right? So it's a testable hypothesis. Now, obviously, it's not easy to do. But maybe we're getting closer. He knew it was impossible in his day. They weren't advanced enough, but maybe we're getting close. James will visit Delbœuf in Liège in 1882. They'll strike correspondence that begins a little bit before. Mutual admiration. Delbœuf, this is responding to James: "You lavish much praise on me in your letter, monsieur. Although I can only accept it in part, you must nonetheless thank you for it. I am almost upset because it prevents me from telling you how much your own writings have made me think. Your lecture on the feeling of effort threw me into a real enthusiasm. To everyone I met, I would ask, have you read Mr. James's little treatise? Read it! Just imagine," he says. "Something new on that little question, and new from beginning to end. It was hard to believe." He really liked James's opinion. Delbœuf will ask James to ask Remler to comment on Delbœuf's paper. Time is free will paper. And Remler will raise the following objection. Do we not introduce energy into the system when we prolong the time it takes for a transfer of motion to occur? You know, coming, and you hold it there. Isn't that introducing energy? That is what others will say too. The common objection to Delbœuf's theory. Now, the Delbœufian response is that these inertial delays, they happen everywhere all the time. That's like inertia. Whenever something, we feel it when we slam the brakes on our car. The car stops and we keep moving. It takes a little bit of time. It doesn't happen right away. There's a little delay. So when this strikes here, there's an inertial delay, and then it goes. If there wasn't that inertial delay, like Newton's inertia, if it wasn't there, then this object couldn't transfer its motion, right? It would hit and it'd take off right away. So it stays there, the motion is transferred, and then it goes. The inertial delay is everywhere all the time. And we don't say that that's a violation of conservation of energy. No one thinks that. And all that Delbœuf is suggesting, let's just prolong it, or you can quicken it. That's probably more viable. We're prolonging it. Okay. Now, James responds to Remler's criticism of Delbœuf, and he says, I hardly think you're doing quite justice yet, but heaven forbid that I should add to my other undone tasks now that of being his champion. I prefer to let him fight his battles of himself. But it seems to me that the rest of his theory amounts to an hypothesis of facts, which we have as yet no evidence for deciding and perhaps never shall have. That's the peculiar thing. Maybe we can never find, we can never do it. James will always stick to that. We can't, it's an insoluble problem. And yet, he says this, and I'm just paraphrasing up here, could a molecule in the brain delay the impulse to move? Could it happen? This does not seem to me an irrational question. Delbœuf himself admits the question is one of molecular happenings. Is it happening or not? Nonetheless, James will continue with his idea that free will problem is insoluble on psychological grounds, and he'll maintain his pragmatic position. Delbœuf, upon receiving James's book, The Principles of Psychology, 1890, he'll write to James and say, you state somewhere that the problem of free will is insoluble on strictly psychological grounds. If it is insoluble psychologically, how could it be solvable otherwise? As for me, my own belief is that this problem is not really a problem from the psychological point of view, for we affirm our free will. It is only through a reasoning whose starting point is scientific or metaphysical, there is no effect without a cause, that we come to, or like conservation of energy, that we come to deny in words our free will. We all kind of feel like we're free, but then it's like, wait a minute, what about the problem of conservation of energy? Other ideas that come in, and then we think, well, maybe not. But from the psychological point of view, it's not really a problem. The problem, therefore, essentially consists in showing that the principle there's no effect of the cause is compatible with freedom, which is what he tried to do. And once this reconciliation is achieved, the affirmation of individual and social consciousness is sufficient to resolve the problem and nothing else is needed. Summing up, James remained committed to his philosophical, pragmatic approach. As you can see there, Delbœuf offered an alternative scientific approach to free will. For Delbœuf, he states that the mission of philosophy, from his point of view, is to develop questions until they can be handed over to the sciences. And this is what he felt he did with the problem of free will by offering a testable hypothesis. If you want to look into this a little bit more, I've written a couple of articles on Delbœuf, on Thomas mechanism, free will, and evolution. And finally, thank you for your time. I tried to put a little wing in there, but it disappeared. Thank you.
There's a lot of questions. Yes, we'll go ahead and start here.
Yeah, could you comment maybe on the points of view of Delbœuf and James concerning the energy, the energy necessary to think when it comes to, let's say, James Clerk Maxwell. He had the Maxwell demon, so to speak, and didn't really factor in the information or entropy production in the thinking of the Maxwell demon, and kind of thought that that was effortless. But we know now that, you know, psychological processes do cost energy and cost entropy, and these don't seem to be factored in these philosophers' discussion.
Right. So good question. Delbœuf would have thought like the activity of the molecules is somehow associated with our thinking, with our thoughts, and you know, for sure we consume energy in thinking. I'm not sure what the problem is that you're seeing.
Well, if you worry about conservation of energy, you can solve the ball problem really easily just by putting a spring there. You put a spring there, it slows down the impact, and then the other ball comes pushing out the other side as long as you hold down the first one.
The spring, the collapse gets locked, and then the tiny amount of energy, so you can have it.
Yeah, no, I mean, it's a matter of limits in terms of these thought experiments. But if you do
Right.
just thinking, I mean, as far as I can tell, based on what Maxwell was saying, he didn't think about the cost of thought. He thought it was effortless.
Yeah. So the thinking goes on. It happens on its own. I mean, you can't really stop it. It's the machine that's just going on. I mean, that's what people who meditate, you know, they spend all their lives trying to, like, you know, stop their thoughts or not think or whatever. It's just going on. And then what we do is we intervene, you know, in directing our thoughts. But it's just happening all the time, whether you know. Yeah, it's true. Well, you know, when you're working on something, you're concentrating. What you're doing, from Delbœuf's point of view, is, and James too, is you're resisting intrusive thoughts, and you're holding certain thoughts in your mind. You're resisting others, and it does get tiring.
Yeah, thanks for your presentation. I specifically selected this session this evening, and I'm not disappointed, because the question of free will is super interesting. I'm developing a rigorously formalized new version of memetics, and when in this formalism's memes continuously self-replicate, like you were just saying, that the thoughts are going on. We experience this in concrete terms, and you're nodding, and that you've done that a million times because they're self-replicating. You could say that you have habits, but actually they are doing this thing. And when we then look at what's really going on, I don't see any delay in this fitting in, mainly because of simply the principle of stationary action, or least action principle, which means that if there were even the tiniest little discontinuity, like if you throw a ball in the air, it makes a parabola. And now when you have these two steel balls, for example, hitting each other, yes, there is some elasticity, and you can literally, with a good enough camera, you see that they sort of go together a little bit, and then they spring out as if there is a spring, because there literally is a spring. So any kind of discontinuity in these curves would immediately violate several laws of physics. The other interesting point, though, is that, which is sort of a counterpoint here today, is that as we now know today, energy in the universe is not conserved because it's expanding. So photons through the redshift lose energy. Locally here, we can feel safe. You know, energy is not sort of dissipating anyhow. But through these 2 points, I find this fascinating, but I don't see free will fitting anyhow in any kind of delay, because it would immediately violate physical laws. So my question is, how familiar are you with the principle of least action or stationary action?
A little bit.
I recommend you really looking into that.
But keep in mind that it's not like if you throw an object, it's going to follow the shortest path when it falls, the principle of least action. But Delbœuf is not suggesting that it's we can stop it in mid-flight. It's only when it hits something else, it's only in the interaction between things that where it's happening. In terms of the elasticity, like I think that like inertia is a thing. It's really a thing. It's more than elasticity that's keeping it there. There's an actual kind of like passive force that holds it there. Newton struggled with the idea. Others have written about it. It's a thing. And finally, I mean, okay, I mean, it's a pretty wild idea, wild theory, but fundamentally, it's testable. We may think, well, we could see if there is, if when someone exercises their will, they are lengthening the delay of some interaction. Suppose an interaction takes like 1,000th of a second, and we always measure it to be that. You know, maybe it's like something going on in the membrane, you know, a receptor in the neuron membrane. It's always 1,000th of a second. And then we predict that when the person exercises their will, in those neurons and nowhere else, it's going to take more than 1,000th of a second. Maybe it'll take half a second. And we've never observed that. And no one's predicted it.
I'm sorry, you keep saying that. Has that been tested and has something been happening?
Well, it hasn't been tested because so few people know about it, you know, and that's something I'd like to change. But in a sense, it has been tested to some degree in Libet's experiments. And I'll leave that to our next speaker.
Great. All right. Unfortunately, we have to move on to our next speaker. Could we please give a round of applause for our last speaker? Great. And we have our final speaker for this concurrent session. Speaker, Anna Bárbara Brito, who's going to be talking about Searle, Leibniz, Searle, Libet, and non-determinism, an analysis of free will in the philosophy of mind. If we could please get a quick round of applause before she starts. Great. Thank you so much. Oh. No, I think we're all, the music threw everybody off. Great.
Ladies and gentlemen, before I start, I would like to say that it is a pleasure to be in this Congress. When I began my research in criminal law, I couldn't predict the importance of consciousness in criminal responsibility. So I thank the Congress organization, which gave me the opportunity to hear so many different matters about consciousness, and also the chance to share my point of view on a topic that lies at the intersection of neuroscience, philosophy, and my primary field of knowledge, criminal law. The relationship between consciousness, voluntary actions, free will, and determinism. My aim is to critically examine the contributions of two major figures, Benjamin, Libet, and John Searle, and to reflect on the implications of their theories for our understanding of human agency. Understood here has the capacity for an alternative action. The debate over free will and determinism is as old as philosophy itself has shown. In recent decades, neuroscience has entered this debate, offering new experimental data and conceptual frameworks, including the concept of consciousness and its role on voluntary actions. However, as I will argue, neither the experimental findings of Libet nor the philosophical models of Searle provide a definitive answer to the scientific and philosophical question of free will versus determinism. Instead, they open new avenues for reflection and suggest that the issue remains unresolved, both scientifically and philosophically. So let us begin with Libet's mind theory, whose experiments in the 1990s have become foundational in the field of neurophilosophy. Libet demonstrates that unconscious neural activity, what he called the readiness potential, yes, so precedes the conscious intention to act by several hundred milliseconds. Specifically, there is a 300 milliseconds gap between the unconscious decision and the conscious awareness of that decision. And then a 200 milliseconds gap between conscious awareness and the initiation of voluntary actions. Libet interprets these findings as evidence that consciousness is not the initiator of voluntary action. But he did not conclude that free will is an illusion. Instead, he proposed a non-deterministic hypothesis that consciousness has a veto power, allowing the conscious self to withhold or permit actions initiate unconsciously. This means that in voluntary actions, control necessarily involves awareness of the decision, which is initially made unconsciously and not through a process of conscious liberation as once thought. Although this process of deliberation often exists, and Libet called these pre-planned actions. Even if it does, there is always a time when a decision is made to act, non-consciously, and the subject only becomes aware of it around 300 milliseconds of a second later. Therefore, contrary to what is usually said, Libet is not a determinist, in the sense that he thinks there is no free will. On the contrary, when confronted with this question, Libet considers that in principle there is free will, since once the subject is aware of the decision to act, he can carry it out or veto it. And this decision to veto, given its nature, is not predetermined, although it is not yet scientifically proven. Libet also points out that it is not excluded that the factors on which the decision to veto is based develop through unconscious process that precede the veto. However, the conscious decision to veto could still be made without a direct specification for that decision by the preceding unconscious process. In other words, Libet believes that there is no experimental proof of a preceding unconscious process specifically direct at the veto. Therefore, a clear distinction could thus be maintained, socially accepted, and also founded, according to Libet, between actions that result from the exercise of free will and, for example, the actions of a person during a psychomotor epileptic seizure, or those carried out by a person with Tourette syndrome. Subsequent neuroscience on voluntary actions have confirmed the main conclusions drawn by Libet. I pointed here some authors such as Haggard and Heimer, Trevena and Miller, Soon, Isaac Fried, just to name a few of the most important. They have confirmed, as I said, the studies of Libet with some variations, but the main conclusions are the one drawn by Libet. But here I would like also to point it out that there are other studies by action neuroscientists that do not agree with the experiments of Libet and his followers. Other authors, such as Schurger, Mel, Maus, believe that Libet's theory no longer applies to deliberate voluntary actions for different reasons that I will not develop in this presentation. But let us proceed with Libet as the focus of my discussion. Libet's theory and its followers is philosophical significant because it maintains a role for consciousness agency, even in the face of compelling neuroscientific data. He further developed the idea of a conscious mental field, an emergent phenomenon of brain activity that could, in principle, exert causal influence without being reducible to neural pathways alone. This position, while speculative and not empirical proven, aligns with our psychological experience and everyday language about choice and responsibility, and its present itself has better found philosophically, namely with Searle. Turning now to Searle, we find a philosophical approach that complements and deepens Libet's insight. Searle argues that human beings act for reasons, not merely as a result of prior physical causes. Our explanation for action are rational. We say, I did A for reason R, not simply A caused B. This requires the existence of a rational agent, a self, capable of deliberation and choice. Searle acknowledged the conceptual possibility that neurobiological process underlies free will. But he insists that this process must include gaps of causal sufficiency, that is, the total state of the neural and conscious system at the moment of deliberation must not be causally sufficient to determine the state at the moment of decision. Similar gaps would exist between decision and action and between the initiation and continuation of voluntary acts. To account for these gaps, Searle entertains the possibility of quantum indeterminacy at the level of neural microprocess, which could support the systemic indeterminism of rational choice. Systemic indeterminism. However, he admits that this hypothesis is far from scientifically confirmed, given the vast gaps in our current knowledge. Furthermore, in our opinion, it should be already be correct and supplemented by Libet's experiments, which demonstrate that there is a time gap of 300 milliseconds between the unconscious decision and the awareness of that decision, and another gap of 200 milliseconds between the awareness of the decision and the beginning of its execution. It also could be complemented, I think, by Penrose's and Amroth's theory of consciousness with the concept of quantum indeterminacy. Searle also raises a powerful evolutionary argument against strict determinism. If consciousness, decision-making were entirely illusory, it would be biologically inexplicable why evolution would have produced such a costly and complex system for rational choice. Unlike other illusions, such as color perception, which confer clear selective advantages, the illusion of free will would offer no such benefit. So, now I would like to compare Libet and Searle. Despite differences in emphasis, Libet and Searle's theories are remarkably close in several respects. First, both reject non-reductionism. Consciousness is not simply the sum of neural events. It is an emergent property of complex systems. Both posit causal efficacy for consciousness. Even if not fully understood, consciousness states play a role in voluntary actions. Both acknowledge categorical differences. Psychological process and neural process are distinct, though related. A very useful analogy here is Roger Sperry's comparison between a rolling wheel and the molecules that compose it. The property of rolling emerges from the arrangement of parts, but it's not present in any single molecule. Similarly, consciousness emerges from neural process, but is not reducible to them. Searle, in particular, frames his unified theory of neural conscious system as a way to move beyond the false dichotomies of Cartesian dualism and mechanism reductionism. As Murphy and Brown point out, if we want to understand human thought and behavior, as well as the behavior of other higher primates, it is necessary to understand the mental as belonging to a higher level dynamic system, that is, the brain in the body, involved in interaction with the world, both physical and social. Libet, for his part, recognized that there is no direct evidence that contradicts the possible existence of a Cartesian-type soul, but he emphasizes that there is also no evidence to support the idea that the I, or the soul, is an identity separate from the brain. So, he bases himself on the idea that the I and the soul are a phenomena emerging from brain activity of a non-physical nature. From here, he presents his theory of the conscious mental field, which would provide communication with the cerebral cortex, with the neural connections and the pathways in the cortex, as a scientific theory that can be tested and experimentally. So, Libet proposed experimental tests for his theory of the conscious mental field, such as stimulating isolated parts of the brain and observing whether consciousness response occur, whilst air, in the absence of direct neural connections. Such experiments could confirm the existence of a unified mental field with causal powers, but not the existence of free will per se. That is, it doesn't demonstrate the existence in this field of free will, but only of the type of the causality from the mental to the physical that is also implied in free will. Both Libet and Searle agree that regardless of the validity of the mental field theory, knowledge of neural structure and function alone can never fully explain the subjective experience of consciousness. The explanatory gap between objective brain process and subjective experience remains. This point is reaffirmed by Libet in this context, quoting, "Regardless of whether the theory of consciousness mental field is valid, knowledge of the structure and functions of nerve cells can never itself explain and describe the subjective experience of consciousness." So, to conclusion, where do we stand? The theories of Libet and Searle, while not scientifically conclusive, are philosophically compelling. They suggest that consciousness causality remains plausible. Consciousness may play an operative role in voluntary actions. Determinism is not inevitable. There are conceptual and empirical reasons to resist the reduction of human agency to mechanism causality. The explanatory gap persists. Neither neuroscience nor philosophy has yet bridged the divide between brain and mind, between objective process and subjective experience. So the debate over free will and determinism is far from settled. As neuroscience advances and philosophical reflection deepens, we may move closer to an integrated understanding. For now, we must recognize the limits of our knowledge and remain open to the possibility that the mystery of human agency is not yet fully within our grasp. Thank you. If you have any questions, please feel free to ask.
Great. All right. Questions. All right. I'm going to try to get some people I haven't got yet. So I'm going to get one, and then I'll get you.
Yes, thank you for this presentation. I just want to know your opinion about Schrödinger's experiment, because for me, it really solved when he came here, and then I wrote about him. He really solved the problem of the causality, because the potential that Libet saw. He showed that it's not existent. It's in a normal oscillation. So the causality of when I perceive that I move my finger and it moves, the time is the good one. So when we perceive that we make the decision. This is what I understood of Schrödinger. Yeah. So I just want to know what you think about this.
In my field, law, there is also different opinions. It's very common. And I thought that in science, there would be no such discussions. But when I study the voluntary actions, and I had to read the studies of Libet, mind-time theory, and other studies, I also have had to read the other scientists that have not the same opinion of Libet. So I can't really explain the Schrödinger conclusions, but the way I see it, he thinks that the RP is not unconscious. Is that the premise?
The RP is not an RP. I mean, there's an oscillation.
Yeah.
Okay, and then where Libet computed the RP, it's not there. It's really further in time, and it really corresponds to the moment where we take the decision.
Yeah.
You know, I decide, and then this is what Schrödinger's.
Yes, but it's just one experiment. If you see, you can also read Fried or Sun, and they don't think the same as Schrödinger. So you have different points of view in the same experience. For me, it's a mystery that science has so many doubts. But I think there is no correct answer. Why Schrödinger is right.
I'm going to finish, but for me as a pianist, because I studied this as a pianist, so for me it was very important. Do, re, mi, fa, sol.
Oh, yes.
As a musician, so it's very important to have the fast, to keep the fast decision and the veto. So for me, what Schrödinger really gave me the answer.
You know, there is another distinction that is very important for pianists. That is the automatic actions and voluntary actions. And Libet studied the difference between automatic actions and voluntary actions. Yes. The automatic actions, you don't have the consciousness. You just detect, so it's faster.
Indeed. There's the veto exists, but also the correspondence of the decision, especially in jazz and improvisation.
Yeah.
There's a correspondence when you decide. We could discuss about this, but thank you very much.
Okay, thank you.
My question concerns Libet's experimental design, the setting of the experiment, because if I recall it correctly, it was something like people had to decide to push a button to the left or to the right, something like that, right?
To move a wrist.
To move a wrist
yes,
and then
yes.
see a clock with it.
Yeah.
Right. Okay, but I would say that this is not testing free will. To
Why?
decide to move the wrist without any reason for it is similar to telling you, flip a coin with your imagination and telling me if it's head or tails, which is
Yeah.
basically if you are able to create randomness.
Yeah.
And then I'm not surprised that if you ask a human being to create randomness, we should use some somatic ground for it. And then I'm not surprised the stimuli precedes the conscious decision, because in order to flip a coin mentally, you would just wait and see what my mind produces. You see my
Yeah,
critique?
yes, our decisions are much more complex than to move a wrist.
So this is not about free will.
But I think...
He's not testing free will.
No. But I think Libet has the answer in mind-time theory, because he talks about that critic, and he says that in science you have to, if you want to study a factor like time, Libet was worried with time, you have to study a simple action. You can't not study a decision with, if I'm going to marry with John.
Then I'm sorry, but he's not testing free will. He's testing another thing.
But
That's my...
Yeah, okay.
Yeah, my comment about Libet's experiment is that we have no biological necessity as evolved beings to know the exact moment we make decisions. So this thing about the finger press, the person is asked to make a press the button at an arbitrary time and note the time on the clock.
Yeah.
But there's no reason in evolutionary terms why a person should know the time they make each and every decision. So that's not...
But he only asked the person to see where the clock was when he decided to move the wrist.
Yeah. I don't think that
that is possible.
Naturally possible for a person to do.
But the thing that I thought that it was very interesting in Libet, normally when we talk about neuroscience, we think that the only thing that is important is neural connections. And Libet is always saying that it's impossible to study consciousness without talking with the subjective experience. So we have to interconnect subjective experience with neural activity. It's impossible to study one without the other. So I think Libet don't see decisions as only neural connections. He was really, he said that the proof of subjective experience was so true as the proof of neuron connections. So when he asked the person, where was the clock when you decided to move your wrist? The person answered, and he said, this is a proof, like the other proof that I have with AMG and all of that.
Hi, thank you for the talk. The question I had is, why are we treating veto as a separate or a special case? Isn't it also a thought that arises before we either act or not? Either we continue with the act or resist the act is still a thought that arises, and whatever is more that happens. So that would kind of resist or prevent free will altogether. Because what I heard is vetoing the act is what gives free will a chance to survive. But even vetoing is also a thought that arises.
Yeah.
So there's no free will then.
No, but there's a moment there's a moment where you have the consciousness that you are going to act, and you can veto that.
Yeah, but vetoing is also a thought. I mean,
No, but that is not scientifically proven.
what do you mean?
The papers that I read, that is the veto process is not unconscious.
Veto process unconscious?
It's not unconscious. The functions of veto is not yet proven to be unconscious. So it is something that appears from your consciousness.
So, okay. My understanding is every thought is accompanied by consciousness. Every thought accompanies by awareness, whether to act or continue with the act or to resist. For example, if you are looking forward to something, there is some excitement, there is some consciousness involved. And if you want to resist something, there is again consciousness involved. With every thought accompanies awareness or consciousness. So whatever has more strength ends up happening. Whether you want to continue with the act or veto the act, whatever. Everything is accompanied by consciousness.
Well, I don't know if it is scientifically proven what you said, but I don't agree. Okay.
Okay, that brings us to the end of our session. Please get one more round of applause for our last speaker and all of our speakers. Thank you all for being here. Officially it's 7:30, so if you want to still stay around and talk to the speakers, I'm sure they'll be happy to do so. Thank you.